Hi everyone. On this video, I plan on giving an overview of the neural network process, what we're trying to accomplish with it, and how we do it. So, to give some background on this, the overarching goal is to use a neural network to generate a map of the ocean floor based off of a given course map and a small amount of sonar data. So, to begin, we are using a shallow neural network as opposed to the more popular deep neural network. The reason behind that is a shallow neural network is less computationally intensive and has an easier algorithm to use versus a deep neural network, which has numerous hidden layers. That's the key difference. A shallow neural network only has one hidden layer, whereas a deep neural network has multiple. So we're using a shallow neural network. The caveat to that is we need a lot of training data, which is fairly easy to generate, as I'll explain shortly. So to train the neural network, we begin with a course map of whatever area we're trying to map, or with a simulated data map. Now these maps are in the bathymetry.bty format. Say we have a simulated bathymetry file. We then apply 2D Perlin noise to it, and I'll explain what that is and how we use that later. But we apply the Perlin noise to the map to make it noisy. And we do this thousands of times. We then use the simulation software Bellhop, which is from the Acoustic Toolbox package. And specifically we use the Bellhop 3D.exe extension to generate simulated sonar data based off of this noisy map. From here, we compare all of the simulated sonar data to the real data in the case of using a simulated bathymetry file. We compare all of this noisy data to the real data to figure out which one is the most similar and figure out, what pings, what sonar data associated with what curves gives you the true simulated format. Then we apply a policy gradient to get a direction for what's the most accurate way to generate this noise and what's the most accurate way to actually get this real data. We repeat generating new Perlin noise and follow this path optimization. We do this recursively until we get the ideal simulated data. And finally, this output is considered to be very close to what the true bathymetry file will actually be. So that's a very high-level overview of the algorithm. In future videos, I plan on showing you how we actually generate this data, what Perlin noise is, why we use it, and what are the current setbacks.